grade.
Right. That's how I'm feeling.
So do you want to go over any of the review, I guess, before they get here?
I was just looking at number 3. I want to make sure I understood it right. Number 3, it would be the third one that's the categorical, right?
Well, let me see. I selected number 2, a randomly selected brand of toothpaste, but maybe the randomly.
I was trying. I knew it wasn't the zoo animals but I was between 2 and 3, and I wasn't quite sure because they both kind of fit the definition. So that's why I was like sitting there going back and forth. So I probably second guessed myself too much and have the wrong answer too. So
yeah, because I had number 3 circled first, but then I'm like, wait a minute.
Yeah. So you're on the same kind of boat that I am. It's like, is it 2 or 3?
Yeah. So age in years of a randomly selected vehicle. So that's a random one.
Right. So it would be number 2. But
then that one says a random selected brand of toothpaste. So we're randomly selecting toothpaste and vehicles. So I wonder if it's number 1, the number of animals in the zoo. But
when I read the definition for it all, it can be a gender, an age. I'm going back real quick. Just look at my notes or see if I can find it again.
Yeah, it's like the very first one.
Yeah.
Okay, so subjects are in groups according to similarity of some characteristics such as age, income level, political party, specifically take a simple random sample from each group. So that's stratified sampling.
Right.
So let's see.
And then reading categorical, yield data that can only be considered as categories. Categorical variables are labels, and it does not make sense to do arithmetic with them. The following are examples of categorical variables: gender, nationality, job title, telephone number, etc. Even though a telephone number is made of digits, it doesn't make sense to double someone's number, to add 1 to their number, or to say one number is smaller than the other.
So what lesson was that?
Lesson 2 is when we were introduced to it. And then it says we'll talk about it more in lesson 3. So I'm going to go to that real quick. But that one's quantitative data and stuff, so. So really, that lesson talks about it the best, I think, for basic definition of it.
Mm-hmm.
So that's why that one kind of threw me for a loop. And why I went back and forth between 2 and 3.
Well, I wonder if it's both, because brand of toothpaste.
That could be. And
age in years.
And it says which of the following, so it's not just stuck to one. So
yeah, so I wonder if it's both of them.
That's where I'm beginning to wonder, because both of them fit that definition.
Yep.
So,
Okay, and then, so number 1, I put the central limit theorem, and number 2 is the rule of large numbers.
yeah,
And then number 4, I put the parameter as 100 and the statistic as 112.
okay. That one I was trying to decide on too. And it could be me overthinking again too, so. Because it talks about the mean test score in the United States is 100. And then when they randomly selected statistics students, their scores were 112. So that's why I'm going, was the statistic 100 because it was the overall, and the parameter ended up being 112 because it was just a group? But I wasn't sure. Those ones are getting me, so.
20 randomly selected statistics students. So that would, like 20, would 20 be the parameter?
Ooh,
No.
that could, well, that could be. But it says which of these two numbers, so I'm guessing we're sticking with the 100 and the 112.
Yeah. Because the statistic would be 20 randomly selected students took an IQ test, and the mean of their scores was 112. So that's the statistic, because the mean is the middle, and the parameter would be
So the parameter would be the overall it was 100.
Yeah.
Okay, that makes sense. That was another one that I'm like,
Yeah. And then number 5, I put simple random sampling.
yeah,
And 6 is cluster.
yeah,
And 7, I put simple random again.
that's what I have too.
And then 8 is cluster.
Yeah,
9, I have the mean is 4.7711.
mm-hmm,
And then the standard deviation is 1.91199.
right,
You just have to graph for the 5.
yeah. And I have my graph up. I didn't write down the numbers for that one.
I didn't either. And then create a histogram. So I did that and just had it left.
Yeah.
And then,
Yeah.
so you're on number 11, I got negative 0.165.
Right.
And then, are you done with 12?
I just had the last one to do on number 12.
Okay.
And that's all I had, but.
All right. And then
for B is all I had to figure out. But that's simple enough. That one's pretty straightforward.
And then 13, I think, is the mean, because all of the means have to equal 1.
Right. That's what I think. Yeah.
Okay. I had some questions on some of the other ones, but you're not all the way there.
Yeah. Well, I was just going through them. I can talk over them with you. I was just.
Yeah. Well,
I'm just taking my time.
So number 23.
Okay.
What is the mean and standard deviation of the standard normal distribution?
So that was, what lesson was that one? Do you remember?
I think I have number 5 and 6 pulled up still.
Okay. I'm going to them right now, so.
Okay.
What is the mean and standard deviation of a standard normal?
Because I calculated the other ones.
Yeah.
But I don't know, because it kind of says the standard normal distribution.
Yeah, that's what
I'm not really sure about that one. And then number 32, what is the probability that the sample mean GMAT scores for blah, blah, blah. Anyway, so mine was a really tiny number, 3.48 to the negative 13.
Oh.
So the probability that the sample mean, so isn't it Z equals 600 minus the 542 divided by the calculated standard mean, the new one,
Right.
divided by the square root of 15.
Right.
That one.
That's what makes sense to me. And then don't we put that one in the applet? Put your Z-score in the applet, so it's going to be everything on the positive side.
Yeah, and so the number I got was 7.18, which is huge when we're talking about that applet. So I'm not really sure.
Yeah.
I don't know. So what are the mean and standard deviation of the distribution of sample mean scores for all samples? So I think to get the sample standard deviation, you have to find the Z-score.
Right, that sounds familiar.
Or the X with the line over it. Is that the standard deviation? Equals the normal standard deviation divided by the square root of the number.
Right. So this would be our last lesson that we did. Yeah. So I'm just going through it real quick. So the mean of the random variable would be the X variable X with the line over is U. The standard deviation of the random variable is the, oh, my brain just went blank on what those were. The standard deviation divided by the square root of the number.
Okay, so I maybe put my numbers in the wrong spot.
So your Z-score would be the value minus the mean divided by the new standard deviation. Does that make sense?
Yeah.
The O divided by the square root.
So the 31, wait. So the standard deviation is 120.54, and then divide that by the square root of 15.
Right.
Do that real quick and then see what I get for the other answer, because that just did not seem right to me.
And then the value minus the mean is divided by all of that.
That's how I did it. What the heck? Okay, hang on.
Okay.
So I did that one right and got the sample standard deviation was like 31.123, but I'm going to calculate it real quick again.
Okay.
Don't hurt me.
Because I know if I didn't pay attention to how I put everything in, I would have the wrong number. So I had to make sure, especially on my calculator, put the parentheses where they belong.
Okay, so this is maybe where I ran into the question. So if the X with the line over it is the same as the mean,
Mm-hmm.
then the next formula doesn't work because it's Z equals the X with the line over it minus the mean.
Right.
Let me look back in my notes.
Yeah, yeah, and I'm looking through the assignment too, or the readings too. We might need to find the O divided by the square root for the one number. So I'm going back and forth.
Okay, I'm going to try it with these.
Okay.
Well, no, because that's still just standard deviation divided by the square root of n is the x with the line over it. So then how do you calculate the standard deviation of the sample size?
The standard deviation of the random variable is the O, yeah, divided by the square root of the n of our number. Let's see, I'm gonna go see it through and see if, because they have the questions where you can solve as we read through it. Doesn't really talk about that though. So
I can't burn. Oh, scraper. Oh. Ow, that hurts. Ow.
It's annoying. When you're tired. You're tired.
I'm just reading through everything again.
Yeah, that's what I'm
Making sure I don't miss anything in the reading.
I want to go home. What time is it?
I wasn't saying you're annoying.
What is the problem? 32, right? Is the one that
So
we're
maybe
looking at.
it's the original standard deviation that I put in there, and not the.
That's what I'm wondering.
Okay, let me calculate that number. Because it just doesn't make sense the way I was doing it.
Well, yeah, and going through with how they said in that last lesson, it just doesn't make sense.
It'd be nice if they had the answers in this one.
But they don't. I was hoping for the answers too, so I could go through and say, okay, I'm on the right track, but
Yeah,
it's not there.
I think this is right.
Okay, so go with the original standard deviation.
Yep. So the z-score is 1.85, which makes a lot more sense.
Yeah.
So I'll go in and do the probability. 1 point.
And that should be a fairly small number.
Yeah, 0.0322.
Okay, I'm just gonna write that down.
Okay,
Oh,
so
08322.
0.0322. So the z-score is 1.85.
Okay.
And then the probability is
Okay.
0.032.
Yeah. I just figure as I come back to it, that way I can make sure I did it right too.
Yep. So
I don't see anybody else. I mean, Justin had responded to the email before, but he didn't respond to the time one. So,
well,
I
I
wonder-
say we just go for it then,
that's what I'm thinking.
because I don't want to be up all night.
Me either. Okay, I gotta find it real quick. Okay, I'm opening up the quiz now. Hopefully between the two of us, we can figure this out, right?
Yeah. All right. Oh my gosh, 28 questions.
Oh, goodness.
Is it the same questions? No, because there's 32 in that one.
Well, number 2 is,
Which of the following variable? Yeah.
let's click both of them because that's what we decided, right?
Yep.
It locked me out of Facebook because we were in Houston, Texas.
Guess we'll find out if we're right or wrong on that one.
Yeah.
But hopefully right, because we both kind of agree on it. So
Yeah.
number 3 is the same. Put it back real quick. So 100 is the parameter,
That's what I have.
and 112 is the statistic.
Yep.
If that one ends up being wrong, then we know it's the other way around.
Yep.
Okay, number 4, Rotham City has 4 distinct neighborhoods. And that one, wasn't that one question 5 on our review? And we decided that one was the simple random, because that's what I put too.
And then the
That one I
next
kind of debated on too, because it kind of sounded like the cluster sampling where they could take the higher and the lower and then make their decision. But okay, 5. That one was the cluster, right?
Mm-hmm.
Okay. I'm just reading through them again, even though I have the
Yeah,
answer.
I think I might want to also, because it just doesn't make sense that it was only 2 of them out of 5.
Right. At a school fundraiser, the names of every person who attended was entered into the drawing. At the end of the evening, 6 names were selected to receive door prize, which sampling was implemented, and that one I still think is simple random,
Mm-hmm.
because that makes sense. That one was the cluster number. What did I just look at? Number 7. I'm just scrolling through and not even paying attention what number I'm on.
Well, and they're different from the quiz to the paper too, so watch that.
Yeah, that's why I'm reading through them, just to double check. Okay, so this one is our crossroads one. Calculate the mean of the amount spent. So that is different from what our reading was. Right?
Well, no, because you had
No, it's the same.
was the means and the standard deviation. So using software, calculate the mean of the amount sent, and I have 4.77.
Yep.
That's for 3 decimal places.
So 4.7. I got to look at my notes. 7.1, because it's after the decimal.
Okay, 771. And then that one's 1.911.
Yep. 1.9, actually 912. Because it's
Oh, yep.
1.91199.
Yep.
Yes, I created a histogram.
Yes, that was easy. I know I'm going to get that one right.
Yeah, that one I'll get.
Okay. And then 11 wants A, which I put negative 0.165.
And then the other one, I'm going to hurry and calculate that one, because that was the one. That one should be pretty easy to calculate, because it's that number squared. Right?
Yeah. Well, it's, yeah, yep.
It's the, yeah, negative. I didn't realize it was going to be, so that one's the 0.027, right? Is that what you got?
I got
Negative?
No. Let me calculate that again. I got 0.681. So.
Oh, it should be. Yeah, because that should be positive, huh?
Yeah.
Negative.
Oh, yep. I don't know. I must have typed something wrong. So 0.027.
Yep. I don't know why it's still giving it to me negative. Because it should be positive, even in my calculator, but. So let me go down here. 0.272. 3 decimal places. Just double checking to make sure. Because I've went through some of these and been like, oh, wait a minute.
Mm-hmm.
It wanted only 2 on that one, and I put 3 in or something. The quantity is equal to the sum of numbers in the square deviations column. Let's see. Was that one of our questions too? And I missed it? Yeah. So 13 was the mean.
That's
Well,
what yeah.
That's what I'm thinking too. I just wanted to double check. See if I can find myself again. I have too many windows open. Okay, standard deviation of those were, I actually have that up because I was working on that. Point 17 or 0.715.
Yep,
Is that correct?
That's what I have to do. And then false for the next one.
0.175, right? I just wanted to make sure I told myself right.
0.715.
0.715. See, my brain's already tired.
Yeah.
Okay.
And I put extra dural because it's the smallest number, which
Okay.
would be the
What did you say for 15 again? True?
false.
Oh, wait. False, because standard deviation. Okay, so most consistent temperatures. What one did you think it was?
I put the extra dural because the standard deviation is the smallest
It's
number.
Smallest one. Yeah, that's what I was thinking. So, okay. I think I'm caught back up to you.
Okay.
Oh, my computer just kind of paused there for a minute. The number of hours students spend studying for an exam was recorded. The data represented by the blocks plot below. Answer this. What is the third quartile? So that would be.
I'm going to answer 6 because 0, 4,
Right.
6.
That's
Well,
what
it's 2, 4, 6, 8, and 12.
Yeah. That's what I was just looking at. Yeah, I think it's 6. Looking at that blocks plot. That was not my favorite lesson. I don't like box plots. What percentage of data lies between 4 hours and 8 hours? I think that one's is it the 97? Is that right? Are you still there? Hello?
Are you there?
Yeah, I'm there. I'm here.
I don't know what happened. This is so
I'm like-
weird.
We were sitting here talking and then it was gone.
Yeah.
So I was just looking at that one. Isn't that the middle one, right? Or is it the 90, what is it, 97%?
I got to get back to my quiz. Okay. What percentage of the data lines between 4 hours and 8 hours? I put 50%.
Let me look at the,
can't be
yeah,
right.
4 hours and 8 hours. Oh, okay. I see that. I think so. I
But
think so.
maybe it's not that.
Well, let's see. I'm looking. Because I was thinking this was that one rule that was the 66, 97. You know what rule I'm talking about?
Oh yeah, so this mean and having one standard deviation away from it.
Right. That's what I was thinking. It was along those lines. Am I thinking wrong? The quartiles?
Yeah, I think it's 66.
Okay. So just 66.
Okay.
Okay. I had to read. How did they want it in?
I'm gonna just maybe see if I can.
Yeah.
find that more.
I'm double checking real quick too.
So quartile 1, median quartile 2. How did? So if there's 4 equal groups,
Then it would be like 25%, 50%,
I think that's where I
75%.
was getting it, was getting the 50% was because it was 2 quartiles.
Yeah, that makes sense. But let's go back with the 50% because I agree. Looking at that, you go with the quartiles, the 25%, 50%, 75%, 100%.
Okay.
I'm thinking it's the 50.
Well, we'll know when we submit it. Okay.
You just write it as 50.
Yeah.
So for question 19, an observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrations above 10 parts per million are considered a health risk for infants less than 6 months old. The city of Rexburg reports that the nitrate concentration in the city's drinking water supply is between 1.59 and 2.52 parts per million. And the values outside of this range are unusual. We'll assume the U minus 2 O equals 1.59 parts per million. I'm just writing this down so I don't have to keep going back. And then the other one is the 2.52 parts per million. It is reasonable to assume the measured nitrate concentration is normally distributed. Estimate the mean of the measured nitrate concentration in Rexburg's drinking water. That one's not. Is that one really as simple as adding those two numbers together and dividing it by 2?
I divided it by
Okay, I've got
4 because it's 2 on each side.
Oh, yeah, that makes sense.
So I put 2.055.
So if I divide it by 4, it's 0.5. If I divide it by the 2, it's the same answer that you had.
Oh, okay, maybe that's what I did. I don't have my notes here. I just have the answer. Because I did it all in my calculator.
Well, that's my problem with these, is I sit there and do it on my calculator, and then I'm like,
How did I get that?
probably should have wrote down how I did that.
Yeah. And then, so
So are
to
we
get the next one,
So we're thinking that it's just the divide it by 2, right? Because we only have the 2 numbers,
yeah.
5, 7. So 0.257, because we're rounding it to 3 decimal places. So 21, or 20, sorry. Estimate the standard deviation of the measured nitrate concentrations in Rexburg's drinking water. Sit here and do that now.
Mm-mm.
Okay, you want to get tackled again? Rib cage.
What lesson did we do the original standard deviation? Do you remember?
Mm,
Because my brain went blank.
I think. Is it lesson 6?
When I'm
Back to 5 and see if it limit theory.
looking at number 3, that one's not it. I know that. 5. Computing z-scores. Kind of just going through with the contents at the above to see without having to read the whole thing. Because I know it's got to be how we were finding it before, not what we've just learned, where we just have the 2 numbers. I lost you again.
I know. I don't know what the heck is going on.
So it's the value minus the mean is how you find the standard deviation by hand.
So what's the value?
That's what I was just wondering.
She's fine. Why?
Estimate the standard deviation. Okay.
I don't know. I'm trying to figure out how I got this answer. I got 0.232. And let me see. I can figure it out.
So, yeah. Do we find the deviation on both of them and then calculate it from there? Because like going through the example, so we had found that the mean on this one was 38.18. This is just one from the reading on lesson 3. The observation was 38.1. So they did 38.1 minus 38.8 equals -7. That's the deviation from the mean. So that's not standard deviation. Let's see. Sample standard deviation is the sample variance. This is the square root of the sample variance.
Which is 2.055, right?
Yeah. I believe.
I think what I did, let me try it again, was I got 2.52 and I subtracted the mean, which is 2.055.
Okay.
And divided that by 2 because that one's 2 standard deviations away. Right?
Right. Sounds right. So then it would be the negative.
Well, it's 0.232. Well,
Yeah.
0.233 if we round that last one up. Let me fix that. My pencil.
0.233, yeah.
And then if you go the 2.055 plus 0.233 plus 2.055 plus 0.233 plus 0.233, you get that 2.52 at the one end, and then if you subtract it,
You get the other one.
Yep.
Okay. So 0.233 would be the standard deviation.
well, it can't be a negative number,
Right.
so it'd just be 0.233.
Yeah. Yeah. Okay. That, yeah. Makes sense. Okay. Okay, 21. Between what two measured nitrate concentrations do approximately 68% of the values lie?
And then I just put 2.055 plus and minus 0.233.
Okay,
To
yeah.
get those.
And that one would be, and so it'd be the 1.823 and the 2.288, right? For 21? Did I do that right?
Yeah, 0.1823
23 and 2.288. Okay. Just wanted to make sure I did that right. Okay. Use the following. This is the one that we were just discussing that had us confused.
Yeah.
The admissions committees for most Masters of Business Administration MBA programs require the Graduate Management Administration, the GMAT, as part of the application for new students. It has been shown that the scores on the GMAT are normally distributed with a mean of 542.3 and a standard deviation of 120.54. The minimum GMAT score required for admissions to the MAC program in the School of Accounting at BYU is 500, but is rare for students with scores less than 600 to be admitted. What is the probability that a randomly selected student will score a 542.3 on the GMAT? So that one we want to put into the applet, right?
Mm-hmm.
We got to figure it out first, right?
Yeah, we gotta get the C score.
I got Shay.
Z-score.
Mom.
Yeah, I know what lesson this one's from. I just have to go back because I grabbed the wrong tablet with all my notes in it.
Mhm.
So instead of looking for it, I'm going back and forth. Which may be tedious, but
And so the way I did that was I put 0.66 in the applet. Let me make sure. That's not how I did it. What did I do to get that answer?
so 0.66, and then you would just shade just the above, right? And it should be 0.254 or 2.55.
If I put 0.66, how in the world did I get that? I have the Z-score.
I think I lost you again. Did we get you back? Are you there?